JavaScript recently got a new data structure, the map. In this video, I'll talk about map and show you how to use map to organize data from an array by a key. You'll see how to store data to and retrieve data from a map, and how to process data in a map. For this video, you'll need to know the basics of JavaScript programming. I'll be using the D3 library to read the data from a file, so some D3 experience is helpful, but it's certainly not necessary. You'll be able to easily follow along even if you don't know D3. This code is actually part of a larger program I wrote to visualize the data in the data file we'll be reading using D3. If you want to learn more about visualizing data with D3, you can find details of reading and visualizing data with D3 in the Wickedly Smart project, How to Visualize Data with D3. If you've used JavaScript arrays and objects, then you already have a good idea of what a data structure is. An array is a data structure that manages items by index, that is, in a particular order. And an object is a data structure that manages items by property name. A map is different from arrays and objects. First, as of JavaScript ES6, there's no map literal notation, so you create a map using a constructor with new. A map is like a dictionary or hash map. You store values in a map using the set method, and the values always go in pairs. When you use set, the first argument is the key, and the second argument is the value associated with that key. So here, I'm adding two key value pairs to the map, the key orange with the value 1, and the key apple with the value 2. To get the values of the keys back out of the map, I can use the get method. Let's try this code in the console. I'll create a new map in the variable myMap. Now I can add the key value pair, orange and 1, and the key value pair, apple and 2. So now map contains two key value pairs, and you can see how the items are displayed here in Chrome. And I can get the values associated with the keys back using the get method, like this. I'll get the value associated with orange and get the value associated with apple. If I use set to change the value associated with apple like this, you can see that the value in the map is updated. Okay, that's the basics of map, so now let's actually use map in a real application. For this example, we're going to use some temperature data from NOAA. I downloaded daily weather data for a location including high and low temperature from NOAA, and you can get the data along with the code for this video from my GitHub link below. As you can see, the data file has a header row, followed by many rows of data. Looking across the rows, you can see the fields we're interested in: the date, the temperature max, and the temperature min, which are the high and low temperatures for the day. This is a lot of data. It's something like 45,000 rows of data. So I could graph every single data point, but instead, what I'd really like to do is to average the max and min temperatures for each year and graph that average. That'll make the data easier to read and give us an idea of the temperature trends over time. And we're going to use a map to do that. So this video is about how to read in this data and then use a map to group the year data together and find the average. Let's first begin by getting this data read in. In my HTML file, I'm including the D3 JavaScript library here, as well as my own JavaScript file, map.js here. Next, I've got a script to run once the page is loaded that calls the function readData, passing in the name of the CSV data file to read. If you're making the whole visualization, you will also pass along the ID of the element where the visualization will go. But we won't do that part in this video. We're just concerned with the map data structure. Here's what the function readData is going to look like. We'll be using the D3 method, CSV, to read the CSV data from the file. I go through how this method works in detail in the Wickedly Smart project, How to Visualize Data with D3. So I'm just going to do a very quick flyover in this video so you understand the format of the data once it's read in. That's the format we'll be working with when we create the map data structure. The d3.csv method takes two arguments, a URL and a callback function. I'll pass the name of the data file to the first argument, since I've got it in the same folder where I've got my HTML and JavaScript code. For the second argument, I'll pass in the name of a method, process data. When the CSV method reads the file, the same one we looked at a bit earlier, the data from each line of the file will be turned into an object, using the header row names as the property names in the object. The objects that represent each line of the data file are passed to process data one at a time. So, for instance, the first object that's passed to process data will be an object with the property names from the header row, so date, tmax, and tmin, for instance. We'll use process data to pick out the items we're interested in, create an object with just those properties, and return that object from process data. Each of these objects gets returned and collected into an array. Once process data is complete and all the rows of the data have been processed, then a promise object is returned from the CSV method. Promise objects are common across a variety of languages and were recently added to JavaScript. A promise represents the eventual result of an asynchronous operation. Well, D3's CSV method is asynchronous. It uses JavaScript's fetch method behind the scenes to load the data from a file, and once fetch is complete, the CSV method returns a promise object that expects to do something with the result value. In this case, the result is the array of data items that are collected as they get returned from the process data function. In JavaScript, a promise has a then method. This method takes a callback function which expects to get that result value, that array of data items we've collected. So what we pass to then is a function with one parameter, data, which will receive the array of data objects collected from process data. We'll supply a callback function to then to do something with that array, and in that callback, we'll call the function mapData. MapData will take the array of objects, and this is where we'll create a new map object to organize our data. We'll be grouping all the data associated with a year into one key value pair, and you'll see how to do this in just a minute. Once we've got the data organized into a map, we can return that and pass it along with the ID to the graph function, which creates the visualization and puts it into the element with the ID we pass in. Notice that I'm using arrow functions as the callback functions here. If you need a review of arrow functions, which are also fairly new to JavaScript, check out my video on YouTube about arrow functions. Okay, here's the code so far. I'm just going to run this to make sure I'm reading in the data properly. All I'm doing right now is returning the data as it comes in. So we should see the initial data array as it gets processed and passed to the functions. I'm printing the data in the mapData function so we can look at the resulting array, which is the data structure we'll be working with as we create a new map object. I'll load the file, map.html, and you can see that we get a huge array of objects. And opening that up, you can see each object has the data from the CSV file, one row per object. To process the data, I'm just going to make a new object, pulling out only the pieces I'm interested in, which are the date and the high and low temps, which are tmax and tmin. Now I'll return that object from process data. So when we rerun the code, the objects in that big array are now just the pieces we're interested in, and the date has been converted from a string to a JavaScript date object. Now, as you can see, we've got high and low temperatures for every day since June 30th, 1891. We could graph every single day's temperatures, but, well, that's a bit much. So what I've decided I'd like to do is find the average high temperature and average low temperature for a year's worth of data and graph that instead. And this is what that would look like. But how do we do that? How do we actually pull out all the temperature data for 1 year, find the average high and the average low, and do that same thing for every data point in this rather large data set? Well, there's many different ways we could approach this problem. But of course, I'm going to use a map to do it, since that's the whole point of this video. And using a map actually makes for a nice, elegant solution. What we've got now is an array with all our data ordered by date. And what we'd like is to group all the data for a year together so we can easily compute the average high temperature for the data points. In other words, what we'd like is a map where each key is the year and the value is an array of all the high and low temperatures for that year. So can we use an array as a value in a map? Yes, we can. So let's see how. For example, here I'm storing the array with the values 1, 2, 3 with the key array in my map. Let's use the console to try that out. I'll create my map and use set to add the key array with the value 1, 2, 3. When I get the array, yep, that's the value, and you can see in Chrome's console display, that's the value of the key value pair. So here's an outline of how we're going to create the map from the array. Remember, we're going to use the year from the data as the key for each item, and all the temperature data for a given year in an array as the value for the year key. So we'll iterate through the data array, and for each object in the array, we'll get the year from the date property. We'll use the tmax and tmin properties to create a new object. We'll get the array that's in the map corresponding to the year key, or create a new empty array if it doesn't exist yet, and push the new object onto the end of that array. Then we'll set the array back into the map using the year as the key. Here's how we do that in code. I'll first create the new map object and call it data map. Now remember that we're passing the data array into this function, so I'll iterate through that data array using for each. For each datum in the data array, I'll get the year from the date property, that's our key, and use that as the key to get the array from the map. Now, of course, if we haven't created an array yet, there won't be one. So in that case, we'll just create an empty array. I'll then create a new object from the tmax and tmin properties in the datum object and push that onto the end of the array. Then use set to set or update the value associated with the year key in the map. This way, every data point that has the same year, that is, all the high and low temperatures from that same year, gets put into the array associated with the year key in the map. So when this iteration finishes, we'll have grouped together all the data points for 1891, for 1892, and so on up through 2016. Notice that this isn't the most efficient way to write this code, but it is a fairly easy and elegant way to solve this problem, and it does not take that long to execute, so for our needs, it's going to be just fine. I'm going to print the data map once this iteration is complete, so we can compare the data in the data array and the grouped data in the map. So I'll reload the page, and we can take a look at these two data structures. Here's the array that we saw before, and now let's take a look at the map. The first key in the map is 1891, and the value for that key is an array. If I open that up, you can see that the values in the array are the objects with the tmax and tmin high and low temperatures for each day in 1891. Note that we're no longer storing the day associated with the high and low temperatures. But that's okay, because our goal is to be able to easily find the average temperature for the entire year. So the specific date of any one temperature reading isn't that important. If you wanted to store the date along with the high and low temperatures, you could add an extra field to the objects in the map containing the full date from the original data. Now going back to the code, back up at the top, the data that gets returned from the callback to then gets passed to the next callback to then, which is a function that calls the graph function. So in the graph function, data is actually the data map. But we still haven't found the average temperatures. So next what I'm going to do is add an extra step to reduce the temperatures in each key of the map to the average high and low temperatures for a given year. So I'll add in a call to a reduce function that's going to reduce each array in the map to an object with the average max and min temperature for the year. Now remember, the data we pass in to the reduce function is the map, so I'll call this argument data map as a reminder. So how do we find the average of each array in the map? Well, map objects are iterables. That means that we can iterate over a map like we can an array. If you think about arrays and objects in JavaScript, you can iterate over an array using for each, But to iterate over an object, you first have to get the property names and get each property using its name. So you can sort of iterate over an object, but not like you can an array. Well, a map is iterable like an array, so we can just use for each to do the iteration, as in this example here. Another way map is like an array is that the things we put in the map are in order. So if we look again at the map in the console, you can see that because we added the key value pairs in order as we found them in the data array, the data is in order by year in the map. So iterating over a map using for each maintains the order. So we can compute the average by year and then put that data into a new array so that at the end of the reduce function, what we have is an array of objects ordered by year with the average high and low temperatures for each year, which is exactly what I need if I want to graph the data. I'm going to create a new data array to hold the averages, and then we can iterate over the map using for each. The function we pass to for each when iterating over the map has two arguments, the value and the key. If we look again at the simple example I showed before, you can see that the first argument is the value from the map. So in this case, that'll be 1 the first time through and 2 the second time through. And the second argument is the key. So that'll be A the first time through and B the second time through. So in the iteration over our data map, the first argument will be the array and the second argument will be the key or year. I'm going to write a helper function here, average, that will return the object we need to push onto the new data array I'm creating. Remember, this object is going to contain the year, which is the key, and the average of the high and low temperatures in the array. So I'll get that object back from the average function and push it onto the data array. Once the iteration over the map has completed, I'll return that data array, and then that's what gets passed onto the graph function in the next then method of the promise. The final step then is to write the average function. We're going to do that in two steps. First, we'll sum the highs and lows in the objects in the array, and second, we'll compute the average. We're getting the array as the first argument to average, and the key, which is the year, as the second argument. So first, I'll sum the tmax and tmin values in the array. We can do that using the reduce method of the array. I won't go into too many details about reduce here, but if you don't know reduce, it's a way of iterating over the array and accumulating a final value. We pass a function to reduce that takes an accumulator value and the value from the array as we iterate. The second argument to reduce is the initial value for the accumulator. Since I'll be accumulating two values in an object, I'll pass an object with 0 for tmax and 0 for tmin. In the function we pass to reduce, I'll create a new object that adds the tmax value from the accumulator to the tmax value from the array value. And I'll do the same with tmin. Once the reduction is complete, we'll have one object in the variable sum that contains the sum of all the tmax values in the property tmax and the sum of all the tmin values in the property tmin. Then we need to find the average and return an object with the average along with the year. So I'll compute the average for tmax and tmin by dividing the sum values by the length of the array that's passed in, that same array we just iterated over to reduce it. Remember, this array is all the values associated with a given year. So if we have 365 values, we've summed up the highs and lows for all 365 data points. So to compute the average, we divide by 365 here, or whatever the length of the array is. It could be shorter if there's missing data. Then we return the new object from the average function. And remember, this gets returned to the reduce function, which pushes that object onto the data array we're creating. This data array gets passed to the graph function. And I'll display the final data array in the graph function. Let's reload the page now that we've added this code and take a look at the data. And you can see that we have a much smaller array now, 124. Actually, this should be 126 because I haven't shown you yet that I'm actually going to splice off the first and last year. So let me fix that. I'll comment that out real quick. Reload the page and you can see we have 126 items corresponding to the number of years of data that we have. And each item in the array is an object containing the year. and the average high temperature for the year and the average low temperature for the year. This is exactly the format for the data we'd need to create a visualization of the averages. But then the last thing I want to do is to remove that first and last year of data, because those years are only partial data. If you look again at the original data, you can see that 1891 starts in July, and the last year, 2016, only goes up through April. So I'm going to make one modification to the reduce function to remove the first and last years from the data using slice, just before we return the array from reduce. So now that I've added that line back in, I'm going to reload the page, and we can see that we have 124 full years of data for the final visualization. So that's how you can use Map to organize data by year to make it easy to get the average of all the data points for the year. Again, this is not necessarily the most efficient way to write this code, but I wanted to emphasize how Map can help organize data and to make the code as clear and simple as possible. Now that you know how to find the average of the data, see if you can write the code to find the maximum high temperature for the year and the minimum low temperature for the year. If you want to know how to visualize data like this, take a look at the Wickedly Smart project, How to Visualize Data with D3. And that'll step you through how to use D3 to take data in this format and turn it into a great visualization like the one shown here. I hope you enjoyed this video, and I'll see you next time.